Hi, I'm the math guy, Steve. Let's try answering this question. So this question asks us, what are the roots of this polynomial expression here? So 3x cubed minus 5x squared minus 4x plus 6. So how do we find the roots? Well, remember, roots are the same as solutions to an equation, or the same as the zeros for a function. And so why they're called zeros is because we set the expression or the function equal to 0. Okay, and find what x values make that equation true. So here we would say, well, set this equal to 0. We get 3x cubed minus 5x squared minus 4x plus 6 equals 0. Now we need to solve this equation. So how we solve this equation is by, well, first getting 0 on one side, then we can try factoring the other side. Here we can try factoring by grouping because it's 4 terms, but grouping doesn't really work here. So instead, let's use that rational zeros theorem, which says if I plug in factors of the constant term divided by factors of the leading coefficients, then whatever numbers I get, those will be the potential rational zeros of this function. So in other words, let's try using synthetic division to find those potential rational zeros. So how we do that is by, well, let's try 1. Let's see if 1 works. We can try 1, -1, 2, -2, I think are possibilities, or 6 divided by 3 is 2. 6 works as far as potential rational zeros, positive or negative. So, but let's try 1. 1 is always a nice number to try. And so we're going to put that 1 in the corner and put these coefficients outside. Okay. And now we're trying to see if the remainder is 0. That's why it's called a 0. Okay. So first we bring down, in synthetic division, we bring down the first number. So bring down this 3. And then I was a bunch of multiplying and adding. So 1 times 3, we get 3. -5 plus 3 is -2. Multiply, we get -2. Add, we get -6. Multiply, we get -6. Add, we get 0. Okay, it worked this time. Remainder is 0. Meaning I found one of the zeros or roots of this expression. So how do we find more? Well, whatever's left over from our synthetic division, that part is our the other part that we need to find the zeros of. So in other words, we found one of them was x equals 1. Okay, now we need to find the rest of them. So x equals and x equals. And so how we find that is by setting the rest of this equal to 0, meaning we would set, okay, that's 3x squared minus 2x minus 6 equals 0. And now we need to solve this equation. Now, this time it's a quadratic, so we could try factoring. I don't think factoring works this time. We could try double bubble and just guess and check. Okay, but it says it's a quadratic. Use a quadratic formula. Okay, quadratic formula works. Let's try it. So remember our quadratic formula. It says the quadratic formula, I'll sing the song. The quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. Okay. That's Pop Goes the Weasel. Okay, all right. So let's try it again. We're using those coefficients from this quadratic equation. Okay, so here we'd say that's the quadratic formula. Okay, x equals -b, so -2 plus or minus the square root of -2 squared minus 4 times 3 times -6 ac all over 2a, all over 2 times 3. Okay, got it. Okay, I'm not gonna sing it every time. All right. All right, so that gives us what? Okay, 2 plus or minus the square root of -2 squared is 4. Okay, then we get minus, but then 4 times 3 times -6 is -72. So minus -72 means plus 72. Okay, so plus 72 all over 2 times 3 is 6. All right. Okay, so that gives us what? 2 plus or minus the square root of 76 over 6. Now, the square root of 76 is not a whole number, but we can say, okay, break this root 76 down into 2 different factors. So like root 76 can be written as root 4 and root 19. And I do know the square root of 4, which is 2. So we get rewriting this or simplifying that radical, we would say is 2 plus or minus 2 root 19 over 6. So now, a huge part of this is that you definitely want to check this, okay? So that's called a Nike step or check step. Now, when checking it, that just means plug it back into the original, see if we get a true statement. So when solving these or when finding the roots, it's not that bad, okay? Use that rational zeros theorem, and then maybe if you get a quadratic from there, once we find one of the zeros, we get a quadratic, then use quadratic formula or factoring works as well, okay? Always remember, math is everywhere.